Hello everybody. Today we're taking a look at differentiating this type of function here. We've got a function f of x equal to a to the power of x. Now the value x is just a constant that could be, say, 2 or 3 or whatever. It could be 100 if you wanted to. What that number is isn't so important. The important thing is that the function f of x changes depending on what the value x is. And of course, we have some constant for a there. Now, there's a couple of things that we're going to need to remember in this case. Number one, we need to know that if you have some arbitrary function, say for example y of x, doesn't really matter what it's called. Let's say that function is equal to natural log of x. Then its derivative, dy by dx, is equal to just 1 over x, like that. So that's the first thing that we're going to need to know. So we've got, let's put that in a box here for a minute. And the second thing that we're going to need to know is that if you've got some log of a to the power b, for example, then that is the same as saying b times log a, like that. So that's going to be the second thing that we're going to have to know in order to solve this problem using the way that I'm showing you. So from here, the first thing that we're going to do is we're going to take our function and we're going to rewrite it using one of our log rules. So just for simplicity's sake, what I'm going to do is I'm just going to take all of this and say this is just f is equal to a to the power x. We know f is a function of x. We've defined that over here. I just want to abbreviate it a little bit. So then from here, what I'm going to do is I'm going to take the log of both sides. So log, sorry, not log. I want to take the natural log of both sides. Natural log of f is equal to the natural log of a to the power x. And now you can see we can use this log rule over here that we already discussed. So this is going to be the same as x times natural log of a. Okay, and all of this, of course, is still equal to the natural log of f. Now, from here, we can solve the entire thing for our unknown variable over here. So from here, we can say, well, all of this is just natural log of f divided by natural log of a. And that is going to be equal to our variable x. Now, remember that all of this stuff down here, natural log a, is a constant. This value here is our value f, whose value depends on what x is equal to, if you recall that from earlier. So we've kind of got the reverse situation happening now, where we've got some function of x with respect to f, where before we had a function of f with respect to x. So I'm going to, just for a moment, say that all of this business here is equal to 1 over natural log of a times my function natural log of f. And all of this is still equal to my value x. Now I can do something really clever. That means I can now find the derivative of x with respect to f. Whereas before, what we had was finding the derivative of x, the derivative of f with respect to x. And why this helps us, and it kind of seems like this is not really what we want to do, but I'll show you why this helps us. So I want to find dx df, finding my derivative of x with respect to f. Recall that this here, the derivative of that, is just the same situation as we have over here, right? So we can find the derivative of this is just 1 over f. That's just 1 over f. And all of this is just a constant, so that stays as it is. So that's 1 over natural log of a. Okay, so all of this is just equal to, if we simplify this a little bit, this just becomes f natural log a. And now we can find the reverse. We've got dx df here. What we wanted was df dx. So in this case, we can kind of just treat our Leibniz notation, our derivative, like a fraction, and that we want to find the inverse of the whole thing. So from here, it kind of seems like cheating a little bit, but from here, what we can find is that actually df, sorry, that looks horrible, df dx is equal to this. We can just take all of this stuff over here and invert it, right? So we've got some function f times the natural log of a. And recall that this was just some function f of x times the natural log of a, like that. So from here, the other thing that we know was that f of x, what was f of x? That was our original function, a to the power x, right? So this is a to the power x times the natural log of a, just like that. And we're done. This is the derivative of our original function, of our f of x.